Hello, guys. Good morning.
Good morning, sir.
Okay, let's start. Okay, so we'll discuss about the rest of the components, the rest of the topics in Kubernetes. Okay, so now, so we'll have a discussion on Kubernetes network part. I'm audible, right?
Yes, sir, you are.
Yes, sir.
Yes, sir, you are on.
Okay, are you guys preparing on all the concept for Q&A?
Yes, Sandeep.
Yes, sir.
Yes, sir.
Yes.
What about Pooja and Niharika?
Yeah, yes, sir.
Okay, so let me share my screen. Able to see my screen? I have just shared my notepad.
Yes, sir.
Okay, so let's have a discussion on Kubernetes network. Okay, Okay, so why do we refer this when we are saying about a Kubernetes network? Okay, so in Kubernetes, the network refers to uh, how the different components, like the different components in the sense. So when we are saying about the pods, services, and external clients, communicates with each other. Okay, so inside the cluster and outside of it, so-called Kubernetes network, right? So say like we do have implemented pod, we do have implemented services, right? Pods, services, and deployments, and also the external clients. Also, we do communicate external clients in the sense. Say suppose if you want to create your database pod, the code should be implemented, and we can deploy a pod, so that should communicate each other, right? So whenever there is a tables to be fetch the data from database, some schemas that we need to pull, right? So that communicate should happen. Through that, it will happen via the, I mean, inside the cluster and outside of it. So to communicate with each other, we will refer network in Kubernetes. Okay, so say like I'll give a definition here first. Okay, so in Kubernetes, a network refers how different components like pods, services, and external clients communicates with each other from inside the cluster and outside of it. Okay, so called we make use of, we do implement the Kubernetes network. Okay, so basically in Kubernetes, we do also configure the network components, the networking part. So the network refers to how different components like pods, services, and external clients communicates with each other inside the cluster and with each other inside the cluster and outside of it. Okay, outside of it. So basically the communication between inside the cluster and outside the cluster, which we implemented of our component like pods, services, and external clients. Okay, so we do have some of the components that we created, correct? Pods, and also we do have clusters, and also we have services, and then ingress and egress, correct? So let's talk about the pod networking now. Just a minute. always each pod can have a multiple container. Okay, so we can configure multiple container in each pod, and each pod can have multiple container and multiple IPs. Okay, now so I'll give a point here. Each pod gets own unique IP address. Okay, and similarly, and inside pod we do have our containers, correct? So once we create a container, so and the containers shares the same network inside the same pod. Okay, containers shares the same network inside the same pod. Okay, so see, inside our pod we do have our container configured, right? So under spec we do point our containers port number, and we do point the port mapping, right? Network. Okay, so containers shares the same network inside the same pod, and basically communication will happen directly using these pod IPs. Okay, so say like we'll have each pod, like the unique IP address of each pod. That communication will happen. Communication in the sense, say suppose we're able to access the container, right? We do log into pod, we do kubectl exec, and we log into pod, and also we'll log into docker container, right? Docker exec -it, right? So the communication, we are interacting with that application, right? So the communication will happen directly using the pod IPs, right? Okay, communication will happen directly using these pod IPs. Will happen with these IP addresses. Will happen inside our component. See, here ultimately manually? No, right? So once we deployed our pod, so it gets deployed and created an IP address automatically, correct? So that's how it works. And similarly, we do have ingress. So ingress is a network component. It is not the service. Keep in mind ingress and egress. Okay. This networking. So as I already explained, ingress is basically controls external traffic coming into the cluster. Controls in the sense it will allow. See, when we are talking about controls, it will not restrict. Controls means whatever the network should come inside, coming into the network, it should accept it. That's what we call it as control. Okay. So control external traffic coming into the cluster. Okay, so called ingress. And similarly we do have egress. Okay, and this controls traffic going out from the pods to the internal or external service. Okay, so called we do have egress. So normally we do prefer ingress. So basically our application should be interacted with the traffic which is coming into the cluster. Okay, so we also have ingress, and in the ingress controller that we discussed, and we do implemented the ingress, correct? So have you guys completed the ingress?
Yes, sir.
Have you deployed ingress controller? The networking part as a part of ingress and the egress. Okay, and when we are talking about the cluster networking, correct? So how this containers to container communication, and how this pod to pod communication, and how this pod to service communication, right? And external to service communication will happen, right? So by default, see, I'll give a point here. Cluster networking. Okay, so cluster networking, see, when we are saying about the cluster networking, so we do have our pods, we do have our nodes, and we do have our services, and also we do have our external services, correct? External services in the sense apart from our cluster implementation, your websites. Suppose if you wanted to have, see, most probably we prefer, when we're talking about the external services means database, right? Suppose if you want to get data from the database which is hosted in on premises, the database, the data centers that you kept it in some regions, that you want to fetch the data, right? So called the external service, correct, right? So I'll give a points here. Container to container communication. Okay, so similarly we do have pod to pod. Pod to pod communication, and the third, pod to service communication. So pod to service communication, and also we do have external name to the cluster name to the container inside the pod that we deployed. One is the supporting container. Both are accessible. right? Kube API server is configured to assign IP address to services. See, the services IP will get assigned by Kube API server, right? Remember our Kubernetes architecture, we do have Kube API server, correct? This Kube API server is configured to assign IP address to services. Similarly, the kubelet, the node component, correct? Correct, right? Kubelet is configured to assign IP address to nodes. Okay, see, the pod IP will get assigned by network plugin. Network plugins, what are the network plugins? We do have our Calico, Flannel, Wave, and Cilium. These plugins are used or helps to assign the IP address to the pod. Okay, and Kube API server is configured to assign IP address to services. Say suppose when you are getting IP address by default, the Kube API server will automatically assign the IP address to the services. Similarly, the pods, suppose if you are getting IP address to the pods, this pods IP we are getting through the network plugin, which is Calico, Flannel, Waves, and Cilium. And similarly, when we are getting the IP address for nodes, which is from the kubelet, the node component. Okay, inside node there is a component called kubelet. This helps to assign the IP address to the nodes. You getting my point?
Yes, sir.
Okay, so this you need to understand clearly. And also we do have cluster networking types, right? So you might see on IPv4 and IPv6 and IPv4 or IPv6, those we call it as cluster networking types. Okay, so cluster networking types, we do have IPv4, correct, and IPv6, and also both we call it as IPv4, sorry, or IPv6. Okay, so these are all the, see, either we use IPv4 or we use IPv6, or we can integrate both in the same configuration. So that we call it as cluster networking types. You might see this, right? IPv4 and IPv6, the network ingress protocol v4, right? And v4 and v6 that you might see when you describe your pod or node, which is in which network. Okay, so this IPv4, all these three, so this we call it as dual network. Either it may pick IPv4 or IPv6 and be configured. Okay, so this, the network plugin like Kube API server, kubelet are configured to assign only IPv4 address. And similarly, see, these IPv4 and IPv6 are configured via the network plugin. Okay, and Kube API server and kubelet. These three components are helps to configure IPv4, IPv6, and dual network, which is this. Okay, so that we will not get any downtime when the application is up and running. Okay, so I'll give a generic statement here. The network plugin, okay, network plugin, Kube API server, kubelet are configured to assign only for IPv4, IPv6, or also from the dual component. Okay, so this is how the see this we will not assign basically from the YAML configuration by default. So it will picks the network type. So as soon as we configure this plugin or the Cube API server or the kubelet, these three components will come into picture as a part of networking component. Okay, clear with this? Are you guys following or?
Yes, sir.
Yes, sir.
Yes, sir.
And also I do have some of the CNI plugins. I'm gonna list here common CNI plugins. Okay, common CNI. See, when we are talking about CNI, contain the network interface, they'll directly ask for a short term. What is CNI? CNI is the component in the network in the Kubernetes, which is contain the network interface, which has some of the plugins like Calico, Flannel, WaveNet, and Cilium, which interacts with all the services like the pod IPs will get assigned via the network plugin. You can say this statement. Okay, so the common CNI plugins, which is Flannel. Okay, so simple overlay network. The network that we use in Kubernetes, which is overlay, we call it as one of the network, which is simple overlay network. Because see, Kubernetes is dependent with Docker, right? What is the default network in Docker?
Which?
Right? And similarly, we do have the networking part, the simple overlay network, which is from the Flannel, which is integrated with the plugin via the CNI called Flannel. Okay. So also we do have Calico. So this is basically the advanced supports network policies. Okay. Okay, so it supports network policies, and also we do have WaveNet, right? We have written here wave networking. So this is basically encryption network. Okay, and also we do have Cilium. So this is basically the format they use for security and observability. Security and okay, so this is how the common CNI plugins that we do integrate in the Kubernetes cluster. Okay, so as soon as we initiating the cluster, we do integrate with some of the CLIs, which is this. Okay, so when you start your, suppose if you are using in Minikube, we'll have to use -CLI Calico. Okay, so let's integrate this cluster with Calico network. Okay, let's start the instance. Sign in again. And basically the cloud providers, which are AWS or Azure or GCP, they will be having the separate networking component, right? So in the cloud providers, they will provide the customized Calico or Flannel plugins to integrate our infrastructure. Infrastructure in the sense, your Kubernetes cluster itself is your infrastructure, correct? Inside our cluster, we do have our nodes, applications deployed. We exposed our services to the web, right? So they provide some networking, customized networking from respect of the cloud providers. Okay, let's start the instance. And we do have in AWS, we have our VPC, right? And in Azure, we have our VNet, virtual networking, we call it as in Azure. Okay, and in AWS, which is VPC. Okay, so now the instances is up now. Let's log into server. Okay. Here it is. Ubuntu followed by IP auth credentials. Accept. Let's increase the font size. Change settings, appearance, change 18. Apply. Okay. So is this screen visible clearly? Let's clear the screen.
Yes, sir.
Okay. Now we should integrate. We should configure our cluster, correct? So when you are configuring your cluster, only at the time of initializing your cluster, we need to configure along with the network. Okay, now we should check whether we're able to whether our Docker should be available, correct, when we want to configure our cluster. So sudo systemctl status Docker, correct? Sorry, Docker. Now the Docker is up and running. Now we need to integrate our Minikube cluster, correct? So here, so let's go to our Minikube configuration here. Let's download this repo of Minikube. Okay, and after downloading, we'll install this Minikube. So here we are using the default cluster, which is Minikube. Suppose if your cluster is hosted in your cloud, either of AWS or Azure, you will have to download the CNI plugin from the GitHub, and that we need to integrate. Currently, we are using Minikube. Okay, now we installed with the cluster. And no worries, we'll create one cluster and we do integrate everything. Okay. Now see, we need to start the Minikube, correct? So instead of starting with the bare Minikube cluster, we'll start with the networking. We'll integrate with this way. Okay. So this is the command to start with the networking, with integrated with all the plugins, which is CNI plugins, which is this Minikube start -- CNI, which is container network interface, that is Calico as a plugin, right? So we'll run this command. So now the Minikube will get configured within the network where the Calico plugin is integrated with this cluster. Okay, so as soon as we integrates with Calico, we should see the CIDR blocks, which is under which network, right? We do have our network. After the IP address, we see /4/8/16 and /24, correct? We should have configured with CIDR blocks, right? We will see that. Now this cluster is ready with the Calico plugin, which is integrated with the Calico plugin, which is CNI of Calico plugin. Okay, now see, to check the cluster, details, we use this kubectl cluster info. Okay, so as soon as kubectl, okay, kubectl is not found, you need to set the alias, just this. Okay, now we can run this kubectl cluster info. See, this cluster will be having this control plane which is running on this IP from the instances, right? Correct, right? So what is our instances IP? 40 dot the private IP 172 okay, control plane which is running on this IP. Sorry, see, this complete control means our cluster nothing but the control plane, right? Inside our control plane we do have our node component and the Kube API server, etcd, Kube control manager and scheduler. Correct, right? See, that's why the Kubernetes control plane which is running on this swan IP, okay, and the core DNS is running on this IP with the namespace called kube system. Under kube system services, kube DNS and DNS proxy. Okay, so core DNS means each cluster will be having their own core DNS. In our case, this is our core DNS which is running on this. Okay, suppose if we want to use the debug, the complete output of the cluster information, we do run cluster info dump. Okay, I'm gonna run this. We can see number of nodes, pods which are integrated with this cluster. Okay, see here you can see default.conf which is IPv6 by default. You were able to see this, the networking part, IPv4 and IPv6, some of the services we use. And here we do have in terms of YAML format the complete cluster info. Okay, let's go to top. And this represents the metadata of cluster information. Okay, and it gives the name of the name of node and the namespace which is default, and it also gives the UID and the resource version, means whatever the resource that we used here, and creation timestamp it gives when it created. So this is what we can see under the cluster info dump. Cluster info and cluster info dump, okay, are the command that you can make use of that. Okay, and these are all the cluster details is basically. And involve object which is kind node of this minikube itself is a node. Okay, don't get confused with nodes and the cluster. Currently the minikube is open source, the on-premises cluster that we do integrate it here. Okay, and also we do have configured the multiple nodes inside the Kubernetes cluster, right? I wanted to show that. See here you can see the namespace is default. Currently the context is set to default, right? We can also switch this context, right? Host minikube. This is a lengthy output where you can see in a big screen that here, see, involve object which is the kind node, and the name of the node with that we created is this. This will give the complete overview of your cluster. So remember that we have created 2 nodes, right, yesterday, to understand the affinity, node affinity and the pod affinity, correct? That's what it is printing here. See, each and every activity, this gives the cluster info. This data will fetch from the etcd. Okay, etcd means the cluster data, correct? where we store our cluster data, right? Correct?
Yes.
So that's how this prints an output for cluster info dump. Okay, this is what I wanted to show. You can also check your cluster info and the dump, and after integrating with this, after checking this cluster info, we do have our pods with the networking pod to print. See, when you run this kubectl get pods -n kube system, you will see kube proxy here. Okay, so when you see this kube proxy as which is running, okay, this represents, say, we can conclude this our cluster is within the network. Okay, so either we can see CNI or kube proxy. Okay, so here there are two kube proxy, CKV4R and KBD double L. So where we see this kube proxy, so our cluster is within the network. We can conclude that our cluster is within the network. Okay, so either you can see CNI or kube proxy. Okay, and also to know the network CIDR block, we'll run this command kubectl cluster info dump grep followed by this cluster CIDR. We can also see the cluster CIDR block. Okay, so this output I wanted to show it from the this cluster info dump but I could not see in this output. Okay, so that's why I have grepped using the cluster info dump. So this is the cluster CIDR block which is under 16. You're able to understand this /16 which comes under the networking as 16 of the cluster IP is this 10.244.0.4 of the CIDR block. The all the IPs will get assigned from this subnet which is 16. You were able to understand this subnet of 16.
Yes, sir.
Every service has their own subnet which starts from 4, 8, 16 and 24, correct? Correct, right? So
Yes.
currently we are in a subnet of 16 of this CIDR block. The IP will get assigned via this IP only. Say suppose when you run kubectl get pods -o wide. See, what is the IP address of your pod? 10.244.1.2, correct? What is the first two digit? 10.244, correct? So how this IP will get assigned? Through this cluster CIDR block only, correct? 10.244.00 means the rest of the two digit can maybe anything, maybe any number, but our CIDR block defines here is 10.244, correct?
Yes.
Here, the cluster CIDR, which is under 16 of subnet. Similarly, when you run kubectl get nodes, -o wide. Okay, so this IP is assigned by the cluster because as I said, this our control plane, our cluster itself is a node, correct, right? That's why it is giving the IP of this, but the node IP the always should define from the cluster CIDR block, which is this. Okay, clear with this? Are you guys clear or confused?
Clear, sir.
Okay, and also see the pod IPs. Anyways, we are able to see the pod IPs from this command, right? So That's how we can conclude that we are able to see the cluster cider block with the subnet of 16. Any questions and any doubts, guys? So what I'll do share this with, I'll replace it here. See, these plugins are very important. So as soon as you're initializing your cluster, we should also integrate with these plugins, which is integrated with CNI plugins. Okay, clear with this? Any questions and any doubts? And I do have a list of questions. Okay, fine then. So any doubts and any questions here? This networking part. Nobody. Pooja, Viresh, Rohit.
No questions, sir.
Okay, so if no questions, then wind up the session. Let's connect tomorrow same time. Let's have a more concepts discussed in the rest of the concepts in Kubernetes.
Okay, sir.
Okay. Let me stop sharing the screen. I'll share this notes in group. Okay, guys, please be prepared and attend Q&A, because that depends on the discussion that we had in morning, the daily sessions. That depends on the sessions, because if you're not saying the answers in the Q&A, it looks I have not given the proper statement and I have not guided you on the concepts. Okay, no worries. You have to prepare well and need to attend, then only we'll pick your profile for placements. Otherwise you will be in the list only. Okay, thank you, bye bye. We'll connect tomorrow same time. Are you guys sleeping or?
Yes, sir.
Okay, so thank you.
Thank you, bye bye.
Yes.